might hear my one of my coworkers chime in every once in
Oh,
a while.
no worries. That'll be fine.
It's dinner time, so she's a little grumpy.
Oh, is this your pet? I'm assuming.
Oh, Hans, yes. She's a
That's great.
12-year-old lab.
Oh, I love it. Oh, that's great. So, parents, welcome to our Nature Wednesdays where we talk all things nature. We're talking about getting kids outside. We're talking about doing STEM in nature. We're talking about local plants and animals. And today we have entomologist Will Chatfield Taylor with us today, who is studies insects, right? He loves beetles. He loves cicadas. He's actually about to leave on a cool semi-cross country trip collecting specimens and studying a specific species. So we'll let him tell you a little bit more about that in a second. But I want to tell you guys how we met, because this is a really cool story. And I think it is really valuable as parents. If you have that kid who's just digging deep into beetles, or they're really into snakes, or really into birds, or whatever it is that they're into, you can easily connect them with other people that are just like them. They may not always be 10 years old. They may be older, but you can develop these relationships. So I was posting cicada pictures on iNaturalist, and it wasn't last summer. I think it was the summer before, or was it? No, it was last summer. Will contacted me and he was like, "Hey, nice to meet you. I study cicadas," and we kind of got into it. And I ended up sending him some species. Unfortunately, last summer was not good for cicadas, at least not in our area, so we didn't get to send him much. But here's the cool part. My kids, we had some of our students, they collected specimens and we put them together, and they had their names on these tags, and we sent them back to Will. And the cool thing is these specimens go into the backs of museums. And so now I have both of my kids with a cicada specimen in the back of some museum somewhere, and they got to be part of that research. And so iNaturalist is a great way to get connected to scientists, not only in your community, but all around the world, who are studying the things that your kids are already interested in. So super long introduction, but if you guys don't mind, go ahead and chat, put something in the chat. Tell us where you're at, if you don't mind, and that might help us to be able to know what kind of cicadas are in your area. But Will, if you don't mind, give us a little bit of an introduction about yourself, and then let's talk cicadas. Oh, and if I hop out of the picture, Will, it's because I'm responding in the text. I feel like I look rude if I'm looking down while you're talking. So if I hop out, I'm still here. I'm just responding.
All right. Hi, everyone. My name is Will Chatfield Taylor. I am a 35-year-old entomologist. I live here in Palm City, Florida, and I have, for the last, 5 years, been collaborating with Dr. Jeffrey Cole of Pasadena City College, working on a group of western cicadas called Okanagan. And we've been studying everything from their life cycles to their behaviors to their evolutionary relationships. I also identify for the local nature groups here in Florida, various cicada species, as well as being very active on iNaturalist. As Dr. Jenny mentioned, I have been using iNaturalist as a way, especially during 2020, for Jeff and I to find specimens, find people on iNaturalist who have discovered interesting specimens, reach out to them, see if they are interested in maybe collecting for us or donating the specimen that they have. And as a result, we have been able to collect material we never would have dreamed of being able to find, including one or two species that we, actually science itself, thought were extinct.
Nice.
So that in itself is maybe a story for another time that Dr. Jenny can relate to you. So I can go ahead and, would you like me to introduce what I was planning on talking about today?
Absolutely. The life cycles of cicadas is going to be amazing. I think everyone's going to love it.
All right. So yes, today I thought I would talk about the various types of life cycles of the cicada groups here in North America. As you know, the periodical cicadas, brood 10, have been emerging out here in the eastern U.S. Periodical cicadas belong to the genus Magicicada, and they come in two different forms: a 13-year version, which has 5 species, and a 17-year version, which has 3 species. The periodical cicadas, they're quite fascinating. They are only found in the continental United States. It's a life cycle found nowhere else in the world. Scientists are still not quite sure how the periodicity arose, although there are various theories. But some of the various reasons that have been thought about why it arose is predator avoidance. A 17-year life cycle means that if a predator, ate you at the first time, it's likely going to be dead by the time you come out the second. So it's not exactly going to learn that you're a regularly occurring phenomenon. So it can't anticipate you. It's not a very common, but it is a known predator avoidance strategy. And that's another thing that we'll kind of be discussing along with the life cycles themselves, because many of them tie in very closely with how cicadas and also other animals in general can avoid predators. The periodical cicadas, a little bit more about them. I'm sure you've heard the word brood used. Brood is actually just a way to classify the geographic distribution of the cicadas rather than any actual relation to each other. Because their geographic distribution is basically the entire eastern United States, and they emerge in such a bizarre way, it was found to be most easily classified by when they emerge. So if they emerge in this case, Atlanta, the mid-Atlantic, and then up in New York and Maryland. Okay, so we're going to call those brood 10. So the next year, when those ones emerge, wherever they emerge, okay, that'll be brood 11. Some broods have come and gone. There's a few that are extinct. Brood 21 was actually here in Florida. It was a 13-year cicada group that went extinct sometime in the 1870s. The most common one that you run into all over the place are the annual cicadas. Dr. Jenny has quite a few of those living in New Mexico. The various genera, Cacama, Hadua. The most common ones here in the eastern United States, Diceroprocta, Megatibicin, Neotibicin, and they just have the very, as it sounds, an annual life cycle. They come out every year, and there really isn't they don't really have a particular predator avoidance strategy in relation to their life cycle, but they are by far the most numerous in terms of species and genus diversity, at least in North America and possibly in the entire world. Now, the group that I work on and that I know the best are a group that use a proto-periodical life cycle and are primarily found in the genus Okanagana. Proto-periodicity means that they come out in variable numbers in a relatively unpredictable number of years. So it could come out in 3 years, they could come out next time in 5 years. Now this is a particularly interesting way of avoiding predators. And it's also used in conjunction with another strategy that I'll talk about in a moment. But using a proto-periodical life cycle, they don't go for the long term, where they fool a predator by just basically making the predator forget that they even came out. They use their unpredictability to keep a pattern from emerging that the predator can get used to, or teaching their progeny to get used to. Now, proto-periodicity comes in many forms. Some Okanagana have actually developed a more specific period. Several up in the more boreal parts of the United States and Canada have a 8-year life cycle, such as Okanagana ramosa. Okanagana synodica has a theorized, though never proven, potential 17 to 19-year life cycle. It's obviously kind of difficult to study something like that. They're a very difficult group to study in general because, unlike the Emergence cicada, which like to just fly onto you and won't leave you alone, or Neotybusin, which come to lights, Okanagana consists of 58 different species, most of which live in the most inhospitable places in the United States, or 60 feet up in the middle of a cedar tree, buzzing at you, saying, "Please come and get me." Nope, you can't. Which is why I think Jeff and I are some of the first people to really study them, since they were first described by a man named Davis back in the 20s and 30s.
Yeah, catching anything in a tree is like a skill, right?
Yeah.
Yeah.
Especially when it involves whether you want to climb, how much you really want to climb the tree.
And cedar aren't exactly like the softest trees, right? So you're in for a little bit of pain while you're doing it.
It's really not the tree that's the problem. It's the sudden stop at the end when you fall.
Yeah. Little problem.
One of the first papers that Jeff and I put together was actually about a very certain subgroup of these Okanagana that are found in Southern California. A small group of species come out on a schedule that is dictated by cumulative rainfall. And it's very interesting. They only come out after a certain amount of rain has fallen over a long enough period of time. And then they'll emerge en masse. But not only will they emerge in large numbers, they'll emerge, all the species have managed to synchronize their emergences over time, so they come out in large multi-species swarms. This actually sort of mimics the behavior of the periodical cicadas, which come up in such large numbers that they is what is called a selfish herd strategy, wherein you're basically, there's so many out that you stand a pretty good chance of being left alone while your other friends get eaten. So it's a
pretty good strategy. It's a mob strategy, right? Like deer do it, hanging out in herds, and yeah. Well, I have a quick question for you, and I think that this might be a good fit because you're talking about these different life strategies and life cycles, and it's where or how do they live before they emerge, and can an event like human disturbance, like weather events, can it disrupt their cycle?
So yes, cicadas live underground. When they lay eggs, they get laid, and nymphs basically attach themselves to the roots of a tree, and over the various years, the nymphs get more and more developed, and eventually, when it's time to emerge, they release themselves from the root and come up and crawl out of the ground, and they'll find some place on a plant or a tree, and then they'll shed their outer shell. You'll see them all over the place, the little, broken shells, we call them exuvia, and then their exoskeleton will harden and they'll fly off. But as Dr. Jenny said, humans and weather disturbances, it's very hard to say how much of an effect they have. That's actually something being researched with periodical cicadas about whether or not weather events can trigger different offsets in the emergence schedules. One thing Jeff and I are interested to find out is that one of our main study sites for these rain-mediated proto-periodical cicadas was just burned to a crisp last year by one of the fires. So we're not really sure whether it will have gotten so hot that it may have destroyed the nymphs. If anything was probably going to do it, it would probably be that. Just getting so hot, it just heat the ground enough to kill them. As for other weather events, we're not really sure. So many species are affected in so many different ways, some positively, some negatively. It's very difficult to tell.
So we have another question for you. How long do they live in adult form, and what do they eat?
Okay, so adult cicadas actually do not have feeding parts, and they do not live very long. Makes collecting them an extra bit of a challenge. You can generally expect them to be out for 4 or 5 days, and then they die, and make for great fodder for predators who scavenge them on the ground. But you don't have they don't have much of a window to when they emerge. Their business is to attract a mate and to lay their eggs and survive long enough to mate, and that's about it.
I didn't know it was that short. That's really interesting. So I mean, you're looking at about a week, and they're kind of done.
Yeah, well, they emerge over a longer period, so they're spread out, but their actual lifespan isn't that long.
Yeah.
So we have quite a bit of time, and then the emergence period for cicadas over the entire time, we started seeing pictures of Platypedia, which are a western species closely related to Okanagan, showing up on iNaturalist in February of this year. And I had a friend of mine collecting into September of last year. So the whole cicada season can be very long, especially in California.
Right. Yeah. Where the weather's so nice. So okay, so I was always under the impression that the adult forms didn't eat either, but it hadn't been something that I'd really looked up. And when we caught that one that you saw on iNaturalist, the ones when we were up at Santa Rosa Lake, I saw that they had those traditional true bug mouth parts. They have that long, proboscis that they, would stick in the roots in their nymph form. And I was just like, I figured they would have lost that, but it's pretty much a non-functional part. Or is it that they just don't use it? Or was I just found one that looked weirder than the other?
No, you didn't find one that looked weird. That's an interesting question. I'm not sure whether it's what the answer is to that question. Okay. I'm not gonna pretend to know the answer to that one.
That's okay. I'm gonna look and I'm gonna find the picture here in a second. But I was just like, if they don't eat, why do they still have this? And so
they don't really need the nourishment because they've been building up the energy reserves the entire time as a nymph underground. So when they emerge, they can just basically use up all their energy. And then that's why they die so quickly, is because they're not feeding.
Right.
So I don't know if maybe it's a vestigial part of the general Hemiptera anatomy from the rest of that group.
Right.
Or whether just that would be my guess, is that it's an evolutionary leftover that they just haven't lost yet.
Yeah. Nice. So I have a couple more questions for you. Sorry, Will. Do you mind if we field these real quick?
Please.
So, the first one is, what data do you collect with your specimens?
Okay, well, that is all sorts of different things. A lot of it is emergence times. A lot of our data for life cycles involves knowing when they came out, and more ancillary data is rainfall in the general vicinity, things like that. But what Jeff and I studied the most are bioacoustics. So we record their songs, especially in this particular group. They're very easy to analyze. They're very simple songs, which is also one of the most interesting reasons to study them. The other thing that we get data or information that we take from them, so to speak, is DNA. So it's always best when we can have very fresh specimens or ones that have been preserved in alcohol. You can get it from older specimens, and we have, but it's easiest with the freshest specimens.
Nice. So following up on their songs, our next question is, so it came in late, but have you talked about the sound they make? It just reminds me of the heat, of heat. It's hot outside, summer, right? But she's asking, is it to attract a mate? And I would love for you to tell us which ones sing. Is it the male? Is it the female? Is it both?
All right, yes. All cicadas sing to attract mates, and it's only the male. Males have specialized organs, morphological structures that are used to produce the sound. Some of them do it different ways, but it's only the males that are ever doing it. And different me going into bioacoustics is dangerous territory because I study it so much. Some of the ones subspecies are able to evolve solely based on their ability to communicate, to recognize mates by their call alone. And in fact, that's a huge evolutionary character for them. It allows them, it's called a prezygotic barrier in evolutionary terms, which basically means that if another species doesn't recognize the male's song, it won't mate with them, which prevents hybridization or mismatch mating. So song is extremely important.
Nice. So let's do a little nature party trick, okay? So we like to teach our parents, something simple that they could teach their kids, that when their kids do it to like the neighbors or, at a block party, everybody's like, oh my gosh, you got the smartest kid ever. So when you flip over a cicada, what do you look for? Do you look for the W? Is it an M? Like, what do you look for under the cicada to tell if it's a male or a female?
Well, it depends on the group, but I guess the easiest way to tell does depend on the group. So
was it? Because I always just was like, if it has a W, it's a male. I could be wrong.
So I gotta move it this way. So this is an Okanagan magnifica, and I'm trying to get it to focus so you can see.
Maybe try putting your hand behind it, right in front of maybe that'll help it focus a little bit more.
That's the other way. There we go. And yeah, this is way harder than I thought it was going to be. So at the rear of the cicada, you can see the small part pointing out. That's called the valve. That indicates that this is a male. And that's one of the features of this particular subfamily of cicadas. It's very hard to see. Sometimes the sound producing organ is very hard to see depending on the species. Other times it's very easy to see. Yeah, that's for a different party trick.
Yeah. Let me see, different party trick. So let's talk, let's do a party trick for the 17-year periodical, because I don't live in Eastern areas, but it's my understanding that they are emerging in a great number this year, and that's really exciting. And so what's like maybe one cool fact, and it could be about the 17-year periodical, or it could just be about cicadas in general. I think one cool fact is they don't live very long and they don't eat as adults. Do you have any other kind of cool fact that kids could share with their friends that other people might not know?
It seems like there's an awful lot of those periodical cicadas, but most people really have no idea how many. The average is, I believe, 1.5 million per acre, I believe.
Oh my gosh.
Yeah.
Are you talking cicadas in general? Are you talking the 17?
Just those periodical cicadas, when they emerge at a density of 1.5 million per acre. There are literally billions and billions of them that come out when they emerge. And brood 10 which is the brood that's coming out now, is the largest of them all.
Really? Okay, so that's a really cool fact. Is that this is the largest emergence of the 17-year periodical.
And cool. Another fun fact is in St. Louis, I would have to look. In St. Louis, there's actually a place where 13 and 17-year cicadas emerge at the same time, coexist.
Right.
So in, I believe it was 1993, both groups emerged at the same time. And it was the first time that had happened since 1777.
Wow.
So you had two groups of periodical cicadas, both in roughly the same densities. Can you even imagine?
Oh, it was deafening. I bet it was deafening. And, Teresa just made a really funny comment in here. She said, no wonder taco stands are cooking them up. There's so many of them.
I didn't need to know that. I was not aware of that. I didn't want to be aware of that. I didn't need to be aware of that.
It's a little delicious treat. Maybe we can look up some recipes.
They're very popular. In Thailand especially. Cicadas are very popular as a food. Insects in general, their protein is 3 times denser than beef.
Oh, I didn't know that fact. I know that they provided protein, but that's interesting.
Oh, high protein density, highest of any animal.
So speaking of all this protein, probably not the tastiest. I don't know. Put a little salt on there. Take the wings off. It could be great. I do have a question for you. So we see this happen, we call it masting in oak trees, when all the trees release oaks together in these, cycles and whatnot. And so, and it causes other organisms in the ecosystem to increase and sometimes cause problems, like mice, for example. So can you tell us a little bit about the ecological connection, the system? So we have all these cicadas. These cicadas are going to feed a lot of animals. What is that going to look like later on in the fall or maybe next year? And what animals are we going to look at as really kind of increasing?
That was an interesting question. I can tell you birds are one of the things that feeds on them the most, as will scavengers on the ground. The conventional biological theory, though, is I can give you the theory about what would happen. When you have that much of a prey source, the predators will be able to breed in greater numbers. But the next year, when the prey dries up, those predators will have a population crash. It happens up, Dr. Jenny, am I right, with the lemmings? Is it in the Arctic? The foxes and the lemmings, I think? It
might. Yeah. I know it happens with mice and ticks up in the northeast. For us here, it happens with deer mice and hantavirus whenever our pines kind of masked out. So
that you would see that with birds. I would think would be the most likely. Magic cicada are very poor flyers. They're very bad dispersers, which is probably the reason that it's interesting. There are a few specimens that have managed to wash ashore in Canada, but even though the broods aren't that far away from the border, there's never been one that's become established in Canada. I believe it's because they've never been able to make it probably across some of the water barriers.
Yeah.
They're just such poor dispersers. They're not, other cicadas aren't like that. Well, not all of them, but magic cicadas specifically. And I apologize, I keep on using the scientific name. When I say magic cicada, is the periodical cicada.
Nice. So I have a really fun comment for you. This is from Elizabeth. She says, I don't think I'll ever eat one, referring to a cicada taco. But for someone who studies them, it seems like a must. So let's ask you, Will, if you had the opportunity to eat a cicada taco, would you do it?
My friend Jeff would probably give me enough grief that I would have to do it. So yes. Peer pressure.
Peer pressure. Yeah, Elizabeth, I will tell you this. My family, we're very adventurous eaters. My husband, myself, we have some friends out here that have collected grasshoppers. We've eaten grasshopper. I'm not saying it was delicious, but I would totally be down for eating a cicada taco. So maybe, well, if you guys ever pass through Albuquerque, we might have to kind of, work that out. So I'll even cook for you. I'm totally down for cooking some cicadas. So
I would eat a cicada. The one thing I've been told not to eat, and this is passed on to me by Jeff, was a water beetle. He said that was a terrible idea. They are very oily, he said. He found that out the hard way.
Or like a spittle bug. That sounds like a bad one to eat.
Yeah, and that also sounds like a bad idea.
Yeah, just not good altogether. You guys, these have been great comments, great thoughts. We've had a lot of fun with you today. Will, do you have any final words of cicada wisdom for us?
Words of cicada wisdom.
There you go.
Well, let me. I can show you this.
Yes.
Is it actually in focus this time?
It is. It looks beautiful.
Yeah, this is a tray, part of my synoptic, which is a complete collection of the genus Okanagana, which is the revision that I'm working on, and it's with the help of scientists like Dr. Jenny and citizen scientists across iNaturalists and our own work that we are working to actually revise the entire group for the first time in its history. So we cannot do this kind of work without people like you. So thank all of you.
Yes. And with that, you guys, he doesn't know what cicadas are rare if you don't post them on iNaturalist. So when you see cicada,
do that.
Yes,
please.
When your kids catch it, take a picture, post it on iNaturalist, and then people like Will can help you identify it, and they get to use it for their research as well. And it's funny, we caught this little tiny baby cicada. It's not a baby. That was
don't remind me.
I know, I'm so sorry. I was taking pictures of it. I was like, this is no big deal, right? And as we were as I was picking it up and doing something, and it just kind of flew out of my hand. And I was like, well, we didn't get to collect that one. I was like, it's not a big deal. So I just posted on iNaturalist. I didn't even text Will. Usually I text him whenever I find cicadas. And then he was like, that one that you posted with the penny, it turns out it's pretty rare. Oops.
Yeah, we're still not quite sure what that is. So if you find a cicada, you can tag me at the little @ Will C-T, and it will get my attention, and I should be able to come in, take a look at your cicada.
Yep. And you guys, Will loves being part of citizen science, and that's what iNaturalist is all about. It's about us going out and connecting to nature, and then cool scientists like Will get to connect with us and help us identify things. So please post your cicadas online. They are about to do their road trip through the West, and they need more data, so help them out. All right. Well, I hope you guys have a wonderful afternoon. Will, stick with me for a second, but I'm going to go ahead and close off this this talk. All right, guys. Have a good one. Bye.
Nice meeting you. Been a pleasure.